You ever ask one of these super powerful AIs what feels like a simple question, and you just get a completely bizarre answer back? Yeah, it happens all the time. But today, we're going to dive into a really cool solution that teaches AI not just to know a bunch of facts, but to actually understand them. We're talking about a leap from just spitting back data to real comprehension. So, this is really the big question, isn't it? We have these massive models trained on literally huge chunks of the internet, and yet they can trip up on the most basic things. So why? Why does that happen? Well, it's not because they don't have enough data. It's because they're missing understanding. Okay, check out this perfect real-world example. An internal company chatbot gets asked, "What is Jennifer Armstrong's title?" The AI confidently says, "Head of Customer Experience." But her actual title was Field Marketing Manager. So what went wrong? Well, it turns out Jennifer had written a ton about customer experience. The AI saw this strong connection, this topical similarity, and just got completely confused. It couldn't tell the difference between what she writes about and what her job is. It's a classic failure of context. All right, so to really get to the bottom of this, here's our game plan. First, we'll talk about the AI's context crisis. Then, we'll look at the first attempt to fix it, called RAG, and see why it doesn't quite work. That'll lead us to the real culprit, the problem of relationships. And from there, we'll get into the solution, Agentic Graph RAG, see how it actually performs, and then talk about what this all means for building AI we can actually trust. So, this really gets us to the heart of the matter, what we're calling the AI's context crisis. It's this bizarre situation where an AI can have access to pretty much all the information in the world, but it just can't connect the dots in a way that makes sense. And look, this is not some minor bug. It is the central challenge. As this quote points out, something like 90% of the issues we have with AI agents come from this lack of context. And if you can solve that, you're not just fixing mistakes. You're building entirely new kinds of products, ones that are reliable, trustworthy, and way more than just a cool party trick. So, how have people tried to solve this problem so far? Well, the most popular method out there is a technique called Retrieval-Augmented Generation. You'll usually just hear it called RAG. It's kind of the default first step everyone takes to try and ground an AI in actual, specific facts. You know, the idea behind RAG is actually pretty smart. Instead of just letting the AI dream up answers based on its massive pre-trained brain, you connect it to an external, up-to-date source of truth. The whole point is to stop it from hallucinating, making stuff up, and force it to base its answers in reality. So let's break down how a simple or naive RAG system works. First, you have the indexing phase. You take all your documents, let's say all your company's internal wikis, and you slice them up into smaller pieces or chunks. Then you store those in a special database. Step 2 is retrieval. When a user asks a question, the system zips through that database and finds the chunks that seem most relevant. And finally, step 3, generation. It takes those relevant chunks, bundles them up with the original question, and hands it all over to the AI to cook up an answer. And here's where it all goes wrong. This system is totally fine for simple questions where the answer is sitting nicely in one single chunk. But what about complex questions? The ones where you have to pull a fact from here, another fact from over there, and a third from way over there? That is when the whole thing just falls apart. And this brings us to the much deeper issue. A standard RAG system is pretty good at finding things that seem relevant, but it is terrible, truly awful, at understanding the relationships between those things. It just can't connect the dots. Okay, think about a really complex, real-world job, digging through a 500-page loan agreement to figure out the exact interest rate. A human expert knows you don't just look up one number, you have to find multiple clauses and connect them. But for a basic RAG system that's just matching keywords, this task is an absolute nightmare. This is a perfect example of what the experts call multi-hop reasoning. To get the right answer, you need to piece things together. You need the spread value, which is buried on page 30, you need the benchmark index, which is way back on page 10, and you need the index floor, which is defined on page 70. A standard RAG system searching for interest rate might just grab that chunk from page 30. It finds one piece of the puzzle, but it misses the other two completely, and so it gives you a wrong or at best incomplete answer. It has no idea that those three facts are all related and have to be combined. Okay, so how do we fix this mess? The solution is a way more advanced system called Agentic Graph RAG. And the whole idea here is to build an AI that actually mimics how a human expert thinks. It does this with two key ingredients, a knowledge graph and a super smart agent. So first up, the knowledge graph. Now, instead of just dumping all your text into a database in disconnected chunks, a knowledge graph creates a structured, a map of your information. It identifies the key things, like a disease, a person, a legal term, and then it explicitly draws the lines, the relationships between them. It's the difference between having a giant pile of books on your floor and having a perfectly organized library with a detailed card catalog. And this makes it crystal clear. The graph doesn't just see the word cirrhosis and the phrase liver transplant as two separate ideas floating around. No, it encodes the very specific relationship between them. Cirrhosis recommends the treatment of a liver transplant. This structure, this understanding of relationships, is the secret sauce that standard RAG is totally missing. Now, having a great map is one thing, but you also need a smart navigator who knows how to read it. And that brings us to the second piece of the puzzle, the intelligent agent. You can think of this agent like a tireless, self-correcting research assistant. Its entire job is to navigate that complex map for you and find the best path to a complete, accurate answer. The way this agent works is with a really powerful self-correcting loop. First, it queries the knowledge graph to get some initial info. But, and this is the critical part, it doesn't stop there. Next, it evaluates that information. It asks itself, okay, is this actually enough to fully answer the question? If the answer is no, like in our loan contract example, it moves to the refine step. It intelligently changes its search strategy to find the missing pieces, and then it queries the graph again. It keeps going through this retrieve, evaluate, refine loop over and over until it's absolutely sure it has all the context it needs. Then, and only then, does it actually generate the final answer. So that all sounds great in theory. But does this whole agentic approach actually work better in the real world? Well, let's look at the numbers, because the proof is in the performance. All right, so this chart shows a super important metric called faithfulness. That's basically a score for how factually correct an answer is, how often the AI is sticking to the facts instead of making things up. Our new Agentic Graph RAG framework gets a score of 0.94. I mean, that is a massive leap in reliability compared to both standard RAG and even a version that uses a graph but doesn't have that smart agent. And the results are even more striking when you bring in actual human experts. For a super high-stakes field like clinical medicine, specialists were asked to rate the answers. Our framework scored a 4.8 on accuracy and a 4.6 on completeness. But look at that last column, safety, a 4.9 out of 5. That is absolutely critical. It shows this system isn't just more accurate, it's fundamentally more responsible and trustworthy in situations where a wrong answer could have very serious consequences. So this all leads us to the bigger picture here. This move towards an agentic, graph-based system isn't just some small technical upgrade. It's a really fundamental step forward in our ability to build AI that we can actually genuinely trust. So if you remember just 3 things from all of this, make it these. Number 1, standard AI just breaks when the answer is scattered across different places and depends on relationships. Number 2, knowledge graphs give us that structured map we need to see how all those scattered pieces actually connect. And number 3, intelligent agents are the smart, self-correcting navigators that use that map to find the complete truth. And that right there is the ultimate point. We are finally moving away from AI that is just a giant, messy database of facts and toward AI that is reliable and, this is huge, auditable. Because the agent is following a logical path through that knowledge graph, we can actually trace its steps, we can see how it got to an answer, and that kind of transparency is a complete game changer for critical fields like medicine, law, and finance. And that leaves us with one last pretty big question to think about. As these AI systems become more and more woven into our daily lives, how are we going to measure them? The true test of their value won't just be how smart they seem. It's going to be how much we can trust them. It's not just about intelligence anymore. It's about integrity.